Okie dokie. So again, factoring out the greatest common factor is something that problem-wise, right, they don't tell you what to divide out or take out. So again, that's something that you have to think about, see what's the biggest thing, and then in this case, we're going to see what's left over. We're not just finding the greatest common factor, but we're actually factoring it out, meaning that factoring is basically undoing multiplication. So if we were to multiply, go backwards, I guess, for an example, and we multiplied 3x into we've done this before. So let's multiply that in. Multiply that. 3 times 2 is 6. 6 squared. 3 times 5, that'll be minus 15x. Okay. So we see that when we multiplied this in, our result shared something in common. Each term shared this 3x in common with it. So going backwards is, well, instead of starting here and being told what to multiply in, we're now starting here and we have to find what to take out, okay? So if we look at this as a original problem, meaning that I didn't just do it. So here you're going to ask yourself, what can I divide 3, 6, and 15 by that's in common? Well, I know I can divide 3 by 3, I can divide 6 by 3, and I can divide 15 by 3. Okay? So I know I can divide by 3. And then when I look at the variables, whatever they may be, I have to say, well, how do they share them in common, and how many do they share in common? So what can I take out? So this has 3 x's, x to the third. This is x squared, so this has 2 x's. But this only has 1 x. So common, what they share, is a single x in common. So this tells me that I can take this set of terms and evenly divide everything by 3x. And sometimes it helps setting it up this way for people. Maybe not everybody, I don't know. So 3 divided by 3 again is 1, right? I'm taking a single x away from x cubed, so that leaves me with x squared. 6 divided by 3 is 2. I'm taking a single x away from x squared, leaving me with a single x. 15 divided by 3 is 5. I'm taking that x away. This has no x's left. Right? So this was what was in here. And since I'm coming full circle, and now that we're at this part, they're not telling us what to take out. So we have to put that in as if we were going to multiply that back in again. So the GCF goes on the outside of the parentheses, and the leftover stuff, what you get after you factor out or divide out that common factor, is what goes in the parentheses. Okay? And in here, when you are, how do you know when you're done? You're done when nothing has anything left in common. No more common factors. Okay? Meaning that this has an x squared, this has an x, but this does not. So they don't share x in common anymore. Big number wise, there's a 1, a 2, and a 5. Can't divide 5 by 2 evenly. So there's no big number that they share in common. So that's how you know you're done. All right, so let's do it. And you're just going to get something that might just say factor, right? Won't be a whole lot of directions. Okay. So if we have this, we look at our big numbers first and say, well, we have a 4 and a 6, right? What can we divide 4 and 6 by evenly that they share in common? So I can't divide 6 by 4 evenly, but I can divide this both by 2, right? And then variable-wise, how many do they have in common for the x's and the y's, right? So this has 2 x's. This only has 1 x. So factor-wise, I can take out a single x. And then when I look at my y's, this has 2 y's, this has 3 y's. So this has only 2 to give. So I can only take out y squared. This is the GCF. Okay. So what's 4 divided by 2? 2. Took that x away from that, leaving me with a single x. Y squared, I'm taking 2 y's away from y to the third, leaving me with a single y. What's 6 divided by 2? 3. Single x, so that factored out, no more x's. And I took also those y squares away, so no y or x's as back number. And if you're not sure, this is where you check yourself. You're going to multiply this back in and see if you get that, okay? So if I multiply this in, I got 2 times 2 is 4. X times x is x squared. Y squared times y to the third. 2 times 3 is 6. And then this carries with it, right? Nothing to multiply with it. It just goes with it. So did I end up with where I started? Yeah. So that's how you know, well, hopefully that you factored it right. Okay. Let's try something else here. And my cat is joining us, so hopefully he will stay out of the way. All right. So now we have 3 terms, and we just look and see what do they share in common. It might not always be as much as you want. So here, 45, 45, well, that's uncommon, cool, but can I divide that by 25 evenly? Sorry, cat's in the way. No. Oh, so then you think, well, what can I divide these numbers by, right? So 25, the only factor for that, the only way to get 25 besides 25 times 1 is 5 times 5. Right? So can I divide 45 by 5? Yep. Yep. So I know I'm going to divide everything by 5. I'm going to factor that out. And then here I'm going to look. What do they have, right? This has m's, this has m's, this has m's. Cool, they all have m's. This has an n. This has 7 of them, but this does not have any. So this doesn't have any to give, doesn't share it in common, no n's in the greatest common factor. So now we look at how many m's we can take out. So this has 2 to give. This has 3 to give. This has 1 to give. So we can only take as many letters, in this case m's, that the lowest one has to give, okay? This only has 1 to spare. Okay? So I can take that m away from each term. And if I kind of do that, this tells me how many I have left over, right? No, this has 1 m left over, this has 2, this has none. So maybe that'll help. So this is the greatest common factor that goes on the outside. And now I'm going to take that term and divide it evenly into everything. So 25 divided by 5 is 5. I'm taking one m away from 2, leaving me with that single m. 45 divided by 5 is 9. I'm taking one m away from 3, leaving me with these two m's. Still has an n on it, that's gonna change. And again, 45 divided by 5 is 9. Took away that single m, no m's left, but this still has 7 n's, or n to the 7th on it. So here, once I'm done, I want to see, is there anything left in common? Did I accidentally leave something in there, right? Well, here I have 5, 9, and 9. Well, number-wise, I can't do anything more because I can't divide 9 by 5. And m, oh, no m, so no more m's in common. N, no n, so no n's in common. This is thirsty work. And if your leading term, the number in front, is a negative, they usually want you to factor out the negative. So meaning something like this. So here, number-wise, I have 42 and 30, right? So number-wise, they're both even. I know I can divide them by 2, but that means I know I can do that, but then 42 divided by 2 is 21. That's 30 divided by 2 is 15. I feel like there's something more, right? So we think about 42 and think of those factors. 42 divided by 3, 14. Can't do it by 4, can't do it by 5, but can do it by 6. Yeah. So here when I do 30, 1 and 30, 2 and 15, 3 and 10, and 6 and 5. So here, if I divide 42 by 6, I get 7. Here, if I divide 30 by 6, I get 5. So between 7 and 5, those are not in common, right? They don't share anything in common. So that's how I noticed to do this rather than this. Can I divide 42 by 3? Yeah, I get 14. Can I divide 30 by 3? Yeah, but I get 10. And so between 14 and 10, again, two even numbers, I could go ahead and divide them again by 2. So if you have, if you have stuff still in common, number-wise, keep going, okay? All right, so I think we settled on 6 as a number. And then variable-wise, again, this has 3 x's to give. This has 2. So we can only take out x squared, or 2 x's. So it's not wrong if we do this. So if I just factor out of 6, so negative 42 divided by 6 is negative 7. Took those 2 x's away, leaving me with a single x. Minus 30 divided by 6 is minus 5. Took those x's away, but this looks weird. At least it does in answering math questions. So generally speaking, if this first number is negative, then you want to factor out the negative here, okay? So rather than dividing out by a positive 6, we're going to divide everything by a negative 6x squared. So a negative 42 divided by negative 6 makes a positive 7. Negative 30 divided by a negative 6 makes a positive 5. So that would be how they want you to answer it. So you want to just be careful on your signs. And last but not least, I'll do this one. So here, our leading term is negative. So I, kind of stole this from the homework. They want you to factor out a negative with that GCF. So we think about 36 and 18, okay? So can we divide 36 by 18? Let's find out. Heck yeah, we can. So that's good. So our number-wise will be 18. And then how many m's can we take? Well, this has 4, but this only has 1, right? So I can only take 1. How many n's? This has 2. This has 3. I can only take as much as this has to give. Okay? So variable-wise, exponent-wise, I can take out a single m and then n squared. Okay? But since this is negative, they want you to divide it out by a negative greatest common factor. So negative 36 divided by negative 18. If you're not sure, just double check yourself before you wreck yourself. Oops, that's not what I meant. Negative 36 divided by negative 18. All right, we get a positive 2. It took a single m away from these 4, leaving us with 3 m's. And I took all those n's away, right? No more n's to give. Now, when I do 18 divided by negative 18, that's when the sign's going to change, right? Positive divided by negative is a negative. I can put a 1 in front of there, but generally speaking, they don't really do that. I took this m away from it, so that's no m's left. But I took 2 n's away from these 3, leaving me with that single n. And that would be that. Okay. Next stop, unfoiling. Woohoo!